Algebra 2, lesson 2.2b, graphing quadratics in standard form. So first we need to know what standard form of a quadratic is. So standard form of a quadratic is y equals ax squared plus bx plus c. So here's an example, right, of a quadratic in standard form. So the a value is always the number that's in front of x squared. The b value is the number that's in front of x. So in this case that would be -1. And the c value is the number that doesn't have an x. Okay, so number 1 here, they want us to write this into standard form and then identify a, b, c. So to work this out, first I'm going to save the negative for the very end. So I'm going to multiply the 3x with the 2x and the 3x with the -5 first. Right? So 3x times 2x, that's 6x squared. 3x times -5, that gives me -15x. Right? Then I'm going to multiply the -2 to the 2x and the -2 to the -5. So that's going to give me -4x, right? And then plus 10. Now I'm going to simplify everything inside here, right? So I'm going to end up with 6x squared minus 19x plus 10. And then I'm going to apply the negative to everything inside the brackets at the very end. So I distribute the negative to everything inside here. So think of that as like a -1. So y is going to equal -6x squared plus 19x minus 10. So now that it's in standard form, we know that our a value is -6, b is 19, and c is -10. Okay? Example 2 here, same thing, let's put it into standard form. So I have y is equal to 3. Now I need to work out this first, the x plus 1 squared. Okay, so this means x plus 1 times x plus 1. Right, then we have plus 2. So I'm going to put this in a bracket because I'm going to work this out first. So I'm going to do the same thing. I'm going to multiply the x to the x and the 1, then the 1 to the x and the 1. So y is equal to, we get x squared plus x plus 1 plus 2. And then we're going to simplify everything on the inside. We get plus 2x plus 1 plus 2. So now we're going to distribute the 3, right? And then we're going to add the 2 at the very end. So the next step, I'm going to distribute the 3. Right, so I'm going to get y is equal to 3x squared. So I'm distributing the 3 into everything inside here. Plus 6x plus 6x plus 3. And then we have the plus 2 at the end. So our final answer will be 3x squared plus 6x plus 5. Then, all right, our a, b, and c values are going to be 3, 6, and 5. Okay? All right, now anytime a quadratic is in standard form and you need to find the vertex for whatever reason, there's a very simple formula you can use, right? So this right here gives you the coordinates of the vertex, right? The -b over 2a, right? Gives you the x value of the vertex. And then once you know the x value, if you plug that into the equation and work it out, that will give you the y value of the vertex. Okay? So whenever the quadratic is in standard form and you need to find the coordinates of the vertex, first find the x value using -b over 2a. So you work that out, and then whatever your answer is, you plug it into the problem, work that out, and that will give you the y value. All right, so let's do an example. So I need to find the coordinates of the vertex, so the x value of the vertex. All right, so the x value of the vertex is negative, and then b, all right, so here was our a, b, and c values. So -b, which is 8, over 2 times a, which is -2. So we end up with -8 over -4, which gives us +2. So we just figured out our vertex, the x value of our vertex is 2. Right? So the x value of the vertex is 2. We need to find the y value. To find the y value, you just take the x, you plug it into the problem, and it'll give you y. So y is equal to -2 parentheses 2 squared plus 8 times 2 minus 3. Then we just work this out. Make sure you follow order of operations. So this is -2 times 4. All right, this is plus 16 minus 3. So we end up with -8 plus 16 minus 3. So all of this is going to give us y is equal to 8 minus 3, which is 5. So we know the coordinates of the vertex is 2, 5. Okay, I'll do another one over here. So we need to find the x value of the vertex. So we're using -b over 2a, right? So this equation right here. So we have negative, so always put the negative first because that's in the equation. And then b is -12, so you need to have another negative. All right, so the first negative is from the equation. The second one is because b is -12 over 2 times a, which is 1. So you work this out, so this will become +12 over 2. All right, so 12 over 2, so that's going to give me 6. So I just figured out that the x value of the vertex is 6. I need to find the y value, so I'm going to plug it in to find the y value. So y is equal to, parentheses, 6 squared minus 12 times 6 plus 4. So I get y is equal to 36 minus 72 plus 4. So if I work all that out, I'm going to end up with -36 plus 4, so -32. So -32 is my y value for the vertex. Okay? All right, so in example 5 here, we've got to do a few things. All right, so let's take it one step at a time. So the first thing, we need to find the vertex, right? We need to find the vertex. So I'm going to find the vertex like I just did previously. So to find the x value of the vertex, right? So here's my a, my b, and my c. So to find the x value of the vertex, I have negative, and then b is -12. 2 times a, which is -2. So I end up with +12 over -4, which gives me -3, right? Now I want to find the y value of the vertex, so I plug it in. -2 times -3 squared minus 12 times -3 minus 3. So I get -2 times 9. Right, so that's going to give me -18. It's going to be +36 minus 3. So I know y is going to be, let me see, that's 18 minus 3, 15. So the coordinates of my vertex, so I know my vertex, the coordinates are x is -3 and y is 15. All right, so I found the vertex. Now I need to decide if the quadratic opens up or down. So how do you know if it opens up or down? Well, it opens up if a is positive. It opens down if a is negative. Well, our a value here is -2, right? So a is equal to -2. So we know that the quadratic is going to open down. Right, since a is equal to -2. So the quadratic is going to open down. And then now they want us to sketch the quadratic, and we need to show the vertex and the y-intercept. Okay, so to find the y-intercept, all right, of the quadratic, you have to remember you're going to make x equal to 0. So you just plug 0 in for x in the problem. So if I have y is equal to -2 times 0 squared minus 12 times 0 minus 3, well, that's easy if you work all this out. This is just 0 minus 0 minus 3, so we just get -3. So we know the y-intercept, right? So the y-intercept, the coordinates are x is 0 and y is -3. Okay? So we need to sketch this now, right? So let me make a sketch, make a quick graph. So it doesn't have to be perfect, but so we just want to make sure we show these points. So first of all, the vertex is -3, right? -3 and then 15. Let's say 15 is right here. So -3, 15, here's my vertex. And I know the parabola is going to open down, so it's going to open down, right? And the y-intercept is 0, right? The y-intercept is 0, -3. So right here, let's say -3. This is my y-intercept, right? So the parabola, we know, is going to open down. It's going to go through 0, -3. Right? Then we can just sketch the other side. Right? We're just making a rough sketch showing this information here. Okay. Now part B, they want us to sketch the axis of symmetry, right? Now remember, the axis of symmetry is like an imaginary, right, dotted line that goes through the vertex, right? Right there. There's my axis of symmetry, right? And identify its equation. Now remember, the axis of symmetry, right, is the same thing as the x value of the vertex. So the x value of the vertex is -3. You see how the axis of symmetry goes through the x value of the vertex right here, which is -3. So we just say x equals -3. Okay. And then the last thing, state the maximum or minimum value. Well, first of all, this parabola has a maximum, right? It has a maximum. First of all, because a is negative and the vertex is the highest point, so it's going to have a maximum. So the maximum value, so it's going to have a maximum, and it's going to equal, well, what's the highest point, right? It's the y value of the vertex, right? So the maximum or minimum value is the y value of the vertex. In this case, the y value of the vertex is 15. And it makes sense because if you think about it right here, this is the highest the parabola goes, it's the maximum, and how high is that? It's 15. All right, so let's take a look at example 6 here. So we need to find the minimum or maximum value. So first of all, we have to remember that when the parabola opens up and the vertex is the lowest point, we have a minimum, right? So when does the parabola open up? If a is positive. And then when the parabola opens down, the vertex is the highest point, so it's the maximum. So when does that happen? When a is negative, right? So the a value tells you when you will have a minimum or maximum, okay? So in this case here, we know a is -3. Since a equals -3, we know we're going to have a maximum. Now we actually have to find the number, okay? So we know it's going to be a maximum, but what's going to be the number? What's going to be the value? Okay. So the minimum or maximum value is the y value of the vertex. So you have to remember that. The minimum or maximum value is the y value of the vertex. So we need to find the y value of the vertex. So let's go find the vertex. You guys know how to do that. So first we need to find the x value of the vertex. So we have negative b, which is -12, over 2 times a, which is -3. So we get 12 divided by -6. So we end up with -2. So we know the x value of the vertex. So we know the x value of the vertex is -2. But we need the y value. So we need to plug in the x to get the y. So we work all this out. This will be +4 times -3. So let's erase that real quick. -3. This will be plus 24 plus 1. So if we work all this out, we're going to end up with 12 plus 1, which is 13. So the minimum or maximum, in this case, it's a maximum. Right? And what's the y value of the vertex? We care about the y value of the vertex. It's 13. Okay. So why do we care about the y value of the vertex when it's a minimum or maximum? Because if you think about it, the y-axis, right? The y-axis on a graph moves up and down, right? So minimum and maximum, how low or how high the parabola is, that deals with moving up and down. Okay, so hopefully that should make sense there for you. All right, so the last thing we're going to talk about is how do we change a quadratic from standard form to vertex form? So first of all, we have to remember vertex form, right? It's a parentheses x minus h squared plus k, right? Well, in order to change from standard form to vertex form, obviously we need to find the vertex. Right? We're going to need the vertex. So to find the vertex, we're using -b over 2a again. So the x value of the vertex, negative, and then what's our b? -20. Divided by 2 times a, which is 2. We'll work that out. +20 over 4, we get 5. So we know the x value of the vertex is 5. To find the y value of the vertex. We just plug it in the problem. And then we work it out. So 2 times 25 minus 100 minus 3. We work all this out, we end up with negative 53. So now that we have the vertex, all we have to do is plug the vertex into vertex form. Now remember, the vertex is the h and the k value, right? So we have y is equal to, now we already know the a value. Remember, a is right here, right? A, B, C, right? A is right here, a is 2. So we know a is 2. Now, if you remember the x value of the vertex, when you write it into vertex form, you have to do the opposite sign. So if it's positive 5 here, we have to put x minus 5, right? Squared, and then the k is negative 53.